Greetings, fellow code whisperers and language alchemists. Ernis here, ready to guide you through the labyrinthine world of large language models, or LLMs, and their ability to, you guessed it, edit code. Now, before you go reaching for the escape hatch, let me assure you, this isn't just about dry lines of code. It's about the future of how we interact with our silicon companions, the very tools we use to shape reality itself. Today, we're diving deep into a fascinating paper titled Edit Bench, Evaluating LLM Abilities to Perform Real-World Instructed Code Edits. Now, I know what you're thinking. Another benchmark, great, but trust me, this one's different. Imagine, if you will, stepping into a bustling programmer's co-working space. Not the sterile, Silicon Valley kind, but the messy, vibrant kind, where real code gets written, and real problems get solved. That's the spirit of Edit Bench. The central argument here is that existing benchmarks for evaluating LLMs in code editing are, shall we say, a bit artificial. They often rely on synthetic data or simplified problems, failing to capture the messy, nuanced reality of how developers actually work. And that's where Edit Bench comes in, a dataset forged in the fires of real-world coding scenarios. Now, let's construct a memory palace to understand the methodology. Picture a grand library, filled with shelves upon shelves of code. Each shelf represents a different aspect of Edit Bench. First, we enter the collection room, where the authors describe their ingenious method of gathering data. They built a VS Code extension, mimicking popular AI coding assistants. As developers used this extension, their instructions, code snippets, and even their cursor positions were captured. It's like a digital anthropologist studying the habits of coders in their natural habitat. Next, we step into the curation chamber, where the raw data is refined and polished. Imagine a team of expert jewelers carefully sifting through rough diamonds, selecting only the most promising gems. The authors filtered the collected data, focusing on Python and JavaScript, and removing trivial or overly similar problems. What remains is a set of challenging, diverse, and, dare I say, real coding puzzles. Then, we float through the harness hall, where the test harnesses come to life. This is where the authors create the environments and test cases needed to rigorously evaluate the LLMs. Think of it as a virtual dojo, where the LLMs can spar with the problems and prove their mettle. Finally, we arrive at the evaluation emporium, where the LLMs are unleashed. Upon Edit Bench, 40 different models, spanning various families and sizes, are put through their paces. The results, as we'll see, are quite illuminating. Now, you might be wondering, what makes Edit Bench so special? Well, let me tell you, it's all about the context. These problems aren't just about generating code from scratch. They require understanding existing code, user instructions, highlighted regions, and even the position of the cursor. It's like giving the LLM a complete picture of the coding landscape, allowing it to make informed decisions. Consider this. Imagine you're a seasoned coder, tasked with fixing a bug in a sprawling codebase. You wouldn't just blindly start typing, would you? No, you'd carefully examine the surrounding code, read the error messages, and try to understand the underlying problem. That's precisely what Edit Bench demands of LLMs. And the real-world applications? Oh, they're vast. Think of AI coding assistants that can truly understand your intent, helping you debug code, add new features, or optimize performance. Imagine a future where coding is more collaborative, more intuitive, and more accessible to everyone. Now, let's talk about the results. The authors found that Edit Bench is, in fact, quite challenging. Only a handful of models achieved a pass rate above 60%. And, perhaps unsurprisingly, closed-source models generally outperformed open-source ones. But here's where things get interesting. The authors discovered that providing additional context, like highlighted code, significantly improved performance. However, adding the cursor position sometimes decreased performance. It seems that LLMs like humans, can sometimes get overwhelmed by too much information. Here's an analogy. Think of it like giving a chef instructions for a complex dish. Highlighting the specific ingredients they need to focus on is helpful, but telling them exactly where to stand in the kitchen might just get in the way. And here's the kicker. Edit bench showed only a weak correlation with existing code editing benchmarks. This suggests that edit bench is capturing something unique, something that other benchmarks are missing. It's like discovering a new species of butterfly in your backyard, something that the textbooks never prepared you for. So, what does all this mean? Well, it tells us that we're only just beginning to scratch the surface of what LLMs can do in the realm of code editing. It highlights the importance of real-world data, contextual understanding, and careful evaluation. It also suggests that there's plenty of room for improvement and that the future of AI-powered coding assistance is ripe with possibilities. In conclusion, Edit Bench isn't just another benchmark. It's a glimpse into the future. A reminder that the most exciting discoveries often lie just beyond the edge of what we already know. So, go forth, explore, and may your code always compile. Ernis, signing off.